Hello, this is Thorsten Lorenz, and today I will show you how to debug a Node.js applications from the C or C++ layer, but add JavaScript to your stack traces as well, so you can see the entire code path that caused a certain function to be called. So in this case, we see here that we have a stack trace in lldb, and these are the C++ functions, but as an added information we have JavaScript function names in here, which is helpful in a lot of cases. So we're going to be using two tools, one being the lldb debugger and then the JBT plugin for that debugger. So first we got to make sure that we have lldb installed, and on Mac OS it actually should be there. On Linux you can install this. All these things that I'm going to show here, they also will work on Linux. So the next thing we got to do is install our plugin, lldb JBT. We're going to install it globally, so then we can source it. And the reason we source it is just to add some environment variables so that lldb can find our plugin. And now we're going to look at the Node version we're using. So first of all, we're going to use a Node version 0.11.13 or greater. And the other things I want to point out is that I have a debug build of Node here. And that's not necessary, but it makes it a lot easier to debug Node, obviously. And on the JBT side, I actually have a wiki here. If you click on build instructions, it will explain to you how you can build Node locally. So now let's look at the app we're going to actually debug. It's just a plain old Node server. So let's start doing that. We're going to launch our debug mode node, and then we're going to use a flag called perf basic prof, and that basically causes V8 to call a function that will then communicate code generation information to JBT. You don't have to worry about that too much, but just make sure you use that flag, otherwise the plugin will not work. And then we're going to give it our file to run. And now we're going to import our plugin, JBT, and we are ready to run our server. Now we're going to wait for the server to start listening on the port, and we will break into it. We're pressing Ctrl+C in order to do that. And now we will add a breakpoint, and we're going to put a breakpoint at UVFS read. And the condition is that the callback is null. And that is the case when we're doing synchronous file reads. And in this case, this example here, which by the way you can find inside the JBT repository by just cloning it. So if you want to play along, you can do that. Anyway, so what we're looking for is synchronous file reads, and whenever those occur, the callback will not be supplied, obviously, because it's synchronous, and therefore it will be null. And that's when we want to break. So now we set the breakpoint, and now we can continue running our server. And down here in another terminal, we will curl to our server and cause it to hit our breakpoint. Now, if in this case we're going to backtrace, which is just built in with lldb, we'll get a stack trace, but a lot of symbols here are missing. So we know that this is actually JavaScript, this being C++, and this is JavaScript that ran. But we don't know what JavaScript it is, and it's kind of useful to know, right? So if we run JBT, it will actually magically add these for you. So here, for instance, we see in frame 7, we're doing a fs read sync, so our suspicion was correct. We're doing synchronous file reads. And if we look further, we can see here that actually our code, README, is causing this to happen, right? So we can then just click on that file, and it will open in my case, in MacVim. And there you go, we found our fsread file sync. So as you can see, it's quite useful to have this tool at your disposal. And this pretty much is everything you need to know to get started with JBT and lldb. But if you're interested, I will explain a little bit more how this actually works. So if you list your breakpoints, you will actually find a breakpoint number 1 here that we didn't add. Actually, JBT added this breakpoint. And it's basically a breakpoint in the function that is called by V8 whenever it's trying to log information about code that it just created, including the symbol information. And basically JBT listens on this breakpoint, and whenever it hits, it will record the information and then continue our process. And in this case, we can see that the breakpoint was hit over 2,000 times, which means that JBT collected over 2,000 symbols. Obviously, that also slows down the process we are debugging a little bit, at least while a lot of code is created by V8. But in my opinion, it is definitely worth having JavaScript symbols in your stack trace to slow down a little bit. So I hope you enjoyed this, and thank you very much for watching.